Dear students, in this video we are going to discuss this differential equation. So as you know, in this playlist we are covering first order linear differential equation, reducible to linear type 1, type 2, type 3 as well as Bernoulli's differential equation also. So in this video we will discuss how to solve this differential equation. See, methods of first order linear differential equation as well as reducible to linear, those are quite simple. But the problem is that when you take any random problem, most of the students get confused how to identify, how to identify it is first order linear differential equation or it is reducible to type 1 or type 2 or type 3 or Bernoulli's. And after that we have to apply the method. So let us see how to identify the given problem belongs to which type, and then we will apply the method and we will solve the problem. Okay. So when you have any random example, first of all you should note down, what is the standard format of first order linear differential equation. Okay, so let me write here dy by dx plus py is equal to q, where p and q are functions of x only. So when you have dy by dx, this term dy by dx, then definitely it is first order linear differential equation or reducible to linear. Okay, reducible to linear is also there, is one more format is there, reducible to linear, that is f dash of y dy by dx plus f of y p is equal to q, right? Sometimes it is not possible to convert the given differential equation in this format, then we try for the second format. Okay, f dash of y dy by dx plus f of y p is equal to q, where p and q are functions of x only. So in both formats one thing is common, that is in right hand side we have q. Q means what? Functions of x only. That means in right hand side we never want any function of y, get it? And in a given problem we have some functions of y in right hand side. That means given problem is definitely not in both of these two types, right, in a standard format. So first of all I will divide both sides by this function of y, which is tan y sin y. So let me clearly mention here, dividing both sides by tan y into sin y. So let us see what will happen. I will divide the first term by tan y sin y. So I will write separate tan y sin y dy by dx. The middle term should be divided by that tan y sin y. So it is tan y upon tan y sin y. And if you divide the right hand side by tan y sin y, it will get cancelled and simply we will have 1 upon x square. So here also tan y will get cancelled. Okay, but still it is looking complicated, right? So what will I do? Do you know 1 upon tan means what? Cot. So that's why I will write it is cot y. 1 upon sin means cosec. So it is cosec y dy by dx plus 1 by x as it is. 1 upon sin means cosec. Here also we can write cosec y is equal to 1 upon x square. Now it is looking better. See, now the right hand side is a function of x only. Okay, but see, we divided by that tan y sin y and it disturbed the first term. Initially we had just dy by dx, that was looking same as this one, it was okay for us. But see, when we divided by that term, so we got some multiple of dy by dx, okay, that cot y cosec y. That means definitely you cannot convert the given problem in this format. Then I should try for the second format, which is reducible to linear, right? So here, there is also one pattern. What is that pattern? Whatever the function of y we have, its derivative must be as a multiple of dy by dx. Okay, so if you have that format, then we can follow the method to solve this problem. So let us see what is function of y here in the middle term. It is cosec y. So what is the derivative of cosec y? Its derivative is minus cosec y cot y And see, we have cot y cosec y. Minus sign is not there, but it is easily adjustable. But the remaining function we got here, so that means definitely I should follow the second format. That means reducible to linear. Okay. See, now the question is how to solve. Method is fixed here. We have to put f of y is equal to u. The substitution is standard. Getting in each and every problem, if you get the problem of this type, substitution is fixed. Whatever the f of y you get, that should be u. So you have to put that thing. So that substitution will help us to reduce this problem into this format. Okay, so if you use this substitution, this reducible to linear will be converted into linear, and then we have a method to solve the problem. So what is f of y cosec y? So let us put it as u, putting cosec y is equal to u. So when you put anything, okay, in case of integration or in case of differential equation, when we put anything, our first task is to find its derivative. Let us find derivative. What is derivative of cosec y? It is minus cosec y cot y and dy, right? dy by dx. So this is a chain rule, getting again derivative of y with respect to x, derivative of u with respect to x, du by dx. So sec y, cosec y, sorry, will be replaced by u, and minus cosec y cot y dy by dx will be replaced by du by dx. But see, we don't have minus sign here, so let us shift this minus sign on that side. I will multiply both sides by minus 1. So we will get this one, dy by dx is equal to minus du by dx. So let us call it as equation number 1. Then 1 becomes, let us see what will happen. Okay, so just a minute, we have this space, let us see what will happen. See, this one will be replaced by minus du by dx, okay. So the entire term will be replaced by minus du by dx. 1 by x will be as it is. Let me write plus 1 by x. Cosec y is u. Okay, that's it. And in the right hand side, 1 upon x square. So now it looks like this, no? But see, we don't have minus sign here at the beginning, getting. So that's why I will multiply both sides by minus 1. So this first term will be plus. So I'm multiplying both sides by minus 1. So this is du by dx minus 1 by x u. This is minus 1 by x square. So now it is linear differential equation, first order linear differential equation. The standard format we have got. The difference is at a place of y we have u. Remaining part is same. So tell me, what is our p? P is a multiple of y. So here p multiple of u is minus 1 by x, that is our p. And what is our q? Is right hand side, which is minus 1 by x square. So I got my p and q. Now the method is quite simple if you get a p and q. So let me tell you first, see, in previous videos we have already covered, but maybe this is first video for you. This is my first video for you. So that's why I will explain that thing again. See, if you have p and q, then we have to perform just 2 steps to get the answer. The first is integrating factor. This is its formula, and the last one, or the second one, you can say the solution. Y e raised to integration p dx is equal to integration e raised to integration p dx q dx plus c. So yes, that's it. So first of all, I will find the integrating factor. Integrating factor is e raised to integration p dx, okay, p dx. So this is equal to e raised to integration. What is my p? Minus 1 by x dx. So minus sign, that minus 1 is a constant. It will come outside the integration. So that minus sign came outside. And 1 by x is still there. What is integration of 1 by x? Log x. Integration of 1 by x is log x. So we got this one. So we can simplify it more. When you have exponential function and logarithmic function, they will get cancelled to each other. But see, there should not be any multiple, okay, as a log. Then they will get cancelled. And if we have a minus sign here, because of that minus sign, we cannot cancel e and log, but we have a perfect solution on that. So there is one property of log and log a. It is log a raised to n. If you have any multiple of log, you can write as a power of a. So minus 1 is a multiple of log. So you can write e raised to log x raised to minus 1. So minus 1 will be shifted as a power of x using this property of log. So now the barrier is removed and e and log will get cancelled to each other, and you will have simply x raised to minus 1. It is nothing but 1 by x. So my integrating factor is 1 by x. So this first step is over, and now we are just one step away from the final answer. Okay. So now the final step is solution. So let me write solution is, so u e raised to integration p dx integration. I'm writing this solution for formula again. Okay, dx plus c. So don't get confused. Okay, actually in the formula we have y, but I'm using u. The reason is that at the end we got the differential equation in terms of u. So that same variable I should use here. Okay, so that's why I wrote u there. So let us put the values. Okay, let me remove this part. U value of u, yes, it is cosec y. So let me write cosec y into this e raised to integration p dx. We have already solved, its value is 1 by x. So it is 1 by x. What is my q? Let us search. Where is my q? Yes, it is minus 1 by x square. Minus 1 by x square. And dx is there. Plus c. So minus sign is constant, no, minus 1. So it came outside. It will come outside. X into x square, you will have x cube dx plus c. Okay, so there is no more space to write. Just make a screenshot of it. Then we will move further. So let us simplify it further. Okay, so left hand side, let us write cosec y into 1, you will have cosec y, and in denominator we have x is equal to minus came outside integration. So we have to integrate that thing. So now the question is which formula we can use here. The formula is simple. Integration x raised to n is x raised to n plus 1 upon n plus 1. But see that x raised to n appears at numerator here, and we have got denominator. No problem, we can shift it to the numerator. X raised to minus 3. 1 by x cube means x raised to minus 3 dx plus c. This is equal to minus 1. I will use the formula. The formula says whatever the power, add 1 in a power. So minus 3 plus 1. So it is minus 2. Same number in denominator. X dx will be removed since we took the integration. Plus c, minus minus plus. Here x raised to minus 2, which is negative. So let me shift to the denominator. So it will be positive. So it is 1 by 2x square. Understood now? This minus minus cancel out. Power was negative. I shifted to the denominator plus c. And here cosec y upon x. That's it. So you can say this is a final answer. Okay. So this formula we use. Let me highlight. And this is the final answer. So in this way we completed this problem. So here we will stop, okay, but in next lecture I will bring the next type to reducible to linear. Okay, next video we are going to cover. Just make a screenshot of it, then we will stop and see you in next video.